So yeah, then let me then write it in chat so everyone can see it. Let me write in general. So that would be on Monday. So this is 29th of November. Chapter 2. Okay, so yeah, this will be on Monday, and remember this Saturday we have a session. Remember that activities 4 and 5 are until this Saturday. So the idea would be that I will take a look on them on Saturday, and then we can discuss some common issues or some common good things you had. You will then submit there, so we can discuss activities 4 and 5 there. So that will be on Saturday, and yeah. So today we're going to continue with the current topics. First of all, let's start. My question: do you have any questions about this vector class we implemented yesterday? So, did you have a chance to take a look on it, and is there anything maybe not clear to you from the vector class? So, okay, then we can maybe go through, and in case you have any questions, then you can ask. So first of all, let's go through all the numbers. The idea is that we created separate class for vector which basically implements the usual vectors we have in math. So I guess all the same rules. As an option, what we can do, we can as one more option, so just read now, we can in math we actually don't have such exact operation on the vectors. We can also compare vectors, for example, but we can implement such comparison, but in math we don't have, so that maybe would be the addition. But so just maybe for your information we can do it. I will maybe take the same solution for now for vector, then create new one today. So one more operation we can do is to check to implement comparison operators. We can do them. So let's say I implement comparison, and then I compare two vectors. And again, we don't have really such a thing as like vector comparing, but there are some cases that we can compare each component, and in case all the components are like less than components from another vector, then we can say that this is true. So otherwise we can say that this is false. So then what we can check if the length is different, then we can definitely say that that's false. So let me return false. I need to return. And also need to find the opposite operator. And by the way, this may be a little bit interesting, since the opposite operator will not be symmetric in this case. Again, let's assume that vectors, let's assume that's the vectors, let's say vector A smaller than vector B. Let's say that this has components, let's say component 1, components 2, and components 3, for example, and so on. It is less than B, no, let's say A1, A2, and A3. So let's say it is less than vector B, let's say it's B1, so B1, B2, and B3, these are numbers, not many numbers, only if all the components are smaller. Okay. So just basically you say that all the components are smaller, otherwise this is false. And in this case it won't be symmetric because there may be the cases when, let's say, A1 is smaller than B1, but A2 is greater than B2. Yeah? So in this case that won't be true. That's why these two operators will not be symmetric. So this is also important case. I would say that important example when the comparison operators are not symmetric. Yeah? So like for here we had symmetric, since it means that if if the comparison equals is true, then the opposite one, not equals, will be false, will always be false. And if comparison operation returns true, then the opposite one returns false. Yeah, and if it returns false, then the opposite one returns true. So this means these are symmetric operations. But for comparison, we introduce this operation which should not be symmetric, because normally, actually, yeah, we can almost symmetric. I would say we normally have a situation when A is less than B, then it means that A is not less than B. Usually it means that I'm talking about any objects, any numbers. Then it usually means that if A is not smaller than B, it means that B is smaller or equals to A. So the opposite one. Here we won't have the opposite. Here we only check if it's smaller or greater. Let me check all the elements of it. So then I can say that it's not equals. If the one is not equals, then of course the result will be false. And then we can again use the same loop and compare. So the same way. So I compare each element and then I check the result. So if vector 1 sorry, if vector 1 element is so if it's not less, then the element from the opposite vector, then it should be, then we automatically say that that's not correct and we return false, otherwise we return true. And so we go through all the elements, we check if this one is not true, and then at the end it means that all the elements from the left vector are less than the elements from the right vector, and then this would be true. But yeah, so then we need to implement the opposite one. So the opposite one no, the opposite one would be actually we can do it sorry, in such a way that we return yeah, we can basically if we compare vector 1 less than vector 2, then greater than vector 2, then I can return vector 2 less than vector 1, so that would be the same. In this case we have this symmetric across the vectors, but not the operations. Yeah, so that should be true, right? So yeah, because if we say vector 1 is greater than vector 2, then that would be the same if we say that vector 2 is less than vector 1. Sorry. Okay, so sorry, let's continue. Yeah. So, and what else? So we can also implement less or equals. So that would also be correct. In this case, we only need to change one sign here. Yeah, and that will be enough. And then we can implement the opposite one. The opposite one would be just simply I change the sequence of vectors, so that would be return. So if I say vector 1 is greater or equals to vector 2, then I can say the opposite one, that vector 2 is less or equals than vector 1. Okay, so I guess for now we're done with all the operations we could do here. So yeah, these are the points. Yeah, so let's again quickly go through. So first of all, we have this this array with the elements we want to store for the vector. So this is the place where we can store the elements, and we want to store the elements. So this is must have here. Yeah, otherwise we don't have a place where we can store the errors. Then I create an indexer. So the same way as in your home task, we have the indexer where which allows us to access the elements in the direct way. Okay. So here it is. Sorry, not here. Where was it? Search. So here we have the indexer. So here I have the indexer, and so this is pretty much same as in your home task, but here I don't have protected setter. It means that I can set the elements from any place I want. Yeah, remember we can define access modifiers for getter and setter, so it means that we restrict the access to or setting the elements there. Okay, so same as in your task. I hope that the indexers are clear for you now, and then I created the option to I created the factory method. So this is static method which creates the object for us. Why do we need it? Because here I can actually in theory this can also be we could do it in using the constructor as well. Yeah, so that would also be fine. So we can redefine constructor and provide these parameters, but this is just an alternative for what and how we can do it. Okay. So yeah, but usually factory methods are needed for the abstract classes or the classes where the returning type may be different from vector type. Yeah, it can be the subclass it can be, let's say, any subclass of vector class, or if we have a situation when the returning type is interface, then it can be any class which implements the corresponding interface provided. So in our case, maybe since we have only one type here, it may be not really needed, but so just for you to know how we can create and use the factory methods. Okay. So then create a simple constructor. Okay. So just by providing the size, this is must have, otherwise I don't know the size of the vector, so I cannot create the vector, I cannot initialize it, I cannot assign the elements there. So that's why this constructor is important. So for others, I implemented the operators. The operator class means I simply sum all the elements from the vectors. First we check if the sizes are the same, otherwise that would be that won't be possible. And then there is the exceptions. exception handled, and separately I defined all the exceptions here, so we can control the flow of our program, since this is what we mostly need when we use exception handling. So that's why I create a separate method which then catches the corresponding exception needed. So, and for the other operations, let's say they're pretty much straightforward. And just we do the validation. So we do the validation, and yeah, by the way, we can also do the validation in the current methods, but I just implemented here. So that can also be possible, but on the other side, so if you simply ignore this, that can also be fine. Yep. Okay. So and sometimes again we used such, like, let's say, some tricks, some shortcuts. For example, if I want to subtract two vectors, then what I can simply do is I can multiply the second vector by -1. So this simply means that this will be the same if I subtract all the elements. So this is the shorter way, and this is the shortcut what we can do to make our code smaller and easier to be maintained and just simply smaller. Okay. So this is one of the tricks we implemented. Yeah. So if I multiply the second vector by -1, that will be the same if I subtract those two vectors. What else? Then the most operations are symmetric. Like if we have equals, then not equals just simply be the opposite one of the results. So the multiplication is the usual multiplication as we have in math. Yeah. So if you multiply two vectors, means that we need to multiply all the elements one by one and then sum them. So if we have multiplication by constant, so it means that we simply multiply each element, and that be it. And also sometimes we may have a situation when we need to switch the positions of the elements, because, like in this case, we see that if we multiply a vector by constant, then let's say that we don't do the opposite direction, then let's try to multiply constant by vector. So let's try to do the opposite. Same kind of multiplication here, and let's say we try to multiply in the opposite direction. So what would it be? So yeah, you see that in this case it is complaining. Okay, so yeah, you see that the position, the sequence of the multiplication operators matters if we so not the operators but multiplication elements, it matters if so yeah, it matters in programming. That's why we need to have the symmetric methods there. Yeah. Otherwise, the program will not understand. And now you see that the issue is solved, so it is not complaining anymore. Yeah, so as I said, equals and not equals should be an opposite one. So it is straightforward. It's comparison of what you said. Yeah. So. Yeah, so in theory we can also shortcut this one with this one. So in theory we can also shorten it. So what we can do, we can say that of course we can check this one, but let's say if here we can also make it shorter. If so then what I can do, I can check basically what does it mean that vector 1 is smaller than, or basically any element is smaller than another one. It means that we have two options. It can be that they are equal, or it can be that the first one is smaller than the second one. So it means that I can check both options, right? So this is basically what I can do here as well. So I can check, one moment, then I can directly write it here. So that will be vector 1 equals vector 2, or vector 1 is smaller than vector 2. And so I can then also make it shorter. And so, and in programming it is always better to search and search for such shortcuts or smaller code and just basically to optimize the code. It's always better to do in programming. Okay. So again, here something means the same. Less or equals means that it basically is always for all the comparisons. So let's say element A less or equal than B is the same as A equals B, or A is smaller than B. Yeah, I mean this returns the same as this one. Yeah, so this is also what I suggest you to remember in such cases, and we can make the code shorter. Yeah. So that's why I can write it here and make my code shorter. So implementing equals, this is much straightforward. Get hash code, we will talk about maybe hash codes a little bit later, but this is required, so let's then do it. And multiplication, as I said before, and the validation. Okay, so I guess then now we can finalize this. Do you have any questions? You have this code available, so you can check it in GitHub. So in case you have any questions, please ask. And now we can maybe move to our today's session. Remember that yesterday we also talked about lambda expressions. So today maybe let's have some examples with them. So lambda expressions are mostly used, so this is, let's say, relatively new syntax. We usually call it as a new syntax, and the idea for them is that they are mostly used on the collections. So it's not only in C#, I would say in lots of programming languages. It is available now, and mostly it's used when working with the collections. Or, I mean, in such languages that these may be the tables, not really database tables, but some kind of internal tables which are available in code, like the arrays or something similar. So basically the place where the data is stored and located. So using some lambda expressions, you can apply the filtering, you can apply the selecting, grouping, mutating, so changing the values on the table. So this is mostly achievable using lambda expressions. So let me the project, create a new one. So folder. Oh no, sorry, that demo. Oh no, okay, that one demo. That's correct for now. So this is then today's demo, and then I add to the solution. This should be correct. Okay. So yeah, be able to work with the one be able to use the one expressions. What we can do, we can use first we need to use collections just in case, but so this is normal usage that we use the collections. So let's say okay, we'll use generic collections, and I will also use wink here. Okay. So and then the usual approach would be that we have some kind of collection, some kind of data. So let's say we'll talk about the collections also today a little bit later, but for now let's for example, let's say we have the list or the array list. It doesn't matter maybe at this point. Oh no, so yeah, let's maybe have the list. Lost. Not lost, but list. So I create a new list. That will be integer list. So then let's say I add some elements there. Say 12. One more elements to the list. Okay. So yeah, of course, when we remember when we call operator new, we when we create the object using the operator new, we need to create the object. So that's why we need to call the constructor. So we cannot forget about the packets to be used here. So, and what we can do, we can apply some operations. Yeah. So let's see what we can do. Yeah, maybe these are the standard ones. Yeah, add, convert to array. By the way, yeah, we can aggregate. For example, we can. So this would simply be for all elements. All elements. Let's check this one. So this, you see, this is the function. This is the function which takes integer. So it goes through all the integer elements and determines if all the elements satisfy conditions. So, for example, let's check if all the elements in the collection are even. They're all paired. So let's say this way. So then, so all means it will go through all the elements. So we see that this is the function. So it passes integer. That's because the collection has the type integer. So that's why I provide the argument. It is here we have the function, then the integer, then I can pass it here, and then so then I need to provide the boolean function, which then checks each element. So the element is x because it will go through all the elements. So the element is x, and here I need to apply condition. So let's check if x modulo 2 equals 0. So check all elements are even. So then let's say we, of course, remember about that. And let's say all the elements, all the collection elements are even. Then else if I can check the opposite one, if they all are odd. So it won't be just simply else, because we can have next case. So then I say this one. And then I write and say that all the elements are odd. And the case else would be if I say the elements are not odd, and yeah, that won't be really correct. I'll say all the collection elements are max 10 maybe, or something like that. So I'm not sure about the best term here, but hope you understand. Yeah, so then I can execute this, and we should have the last option, since we have 7 and 5 here. So these are not odds, or are not even, and others are not odd. So let's check the result. So basically it checks if all satisfy the corresponding condition. And the condition is that what we provide. Yeah, so you see that all the collection elements are next. And let's say that we change some elements. And now we should have the result that all the elements are even. Yeah. So this simply goes through all the elements and checks if condition satisfies. Okay, so as an option, let's check out what else we have here. So we have so you see all the functions, all the functional methods are marked with this arrow down. Okay, so then we can use something similar. We can use any, for example. So then that would be I check any, and then check some elements are even. So then I say there are some that will be enough. So then I check this one, and then I say there are some odds. Some odd elements. All odd numbers. Correct? There are some odds. Yep, so then let's check this case, and then I guess we're done with this one. Okay. Yeah. Okay, so are they all written in the same line? Oh, okay, this because I have right and right hand. That's it's corrected. So now they will all be in a separate line. Yeah, so all means that the condition should be satisfied for all the elements, and any means that at least for one element the condition should be satisfied. Okay, so let's maybe check some more examples. Yeah, basically under each example you can check the description, appends value to the end of the sequence. So this is about the so there are maybe more interesting parameters there. I'll maybe not take a look on all of them. So, but just in case what you can check. Okay, do you have any questions about the lambda expressions when they are used? Yeah.
Yes, I have a simple expression. Can you a little bit more explain regarding modulus? I understand it should return the division reminder according to definition.
Yes.
The percentage sign, I think I haven't used it so much, so could you please explain what it does?
So these are mostly used if you work with the numbers. I guess I have not explained this yet, but for example, when we can, so basically these are used as the reminder, so it means that if we divide, let's say 4, we divide by 2, then it means that the reminder is 0 because we can divide 4 by 2, so the result will be 2 and the remaining part will be 0, so we get this remaining part reminder. And if we divide, let's say 5 by 2, then the result is 2 and 1 is reminder, and this is the result of this operation. So from mathematical point of view, I guess it should be pretty much clear. So this is just the remaining part of the division. When it can be used, I guess I explained this at the beginning of the previous course we had. Maybe some of you do not know it. But what's the key advantage of this operation? The key advantage of this operation is that the result has limited number range. So what does it mean? It means that if we divide by any number, so let's say that if we divide by number 10, what are any number, any integer number we divide by 10, we have modulo 10. So any number, modulo 10, so can you say if we divide, so if we have modulo 10, what are the possible results if we divide, so if we have modulo 10? So do you know what are the possible results? Like any integer number modulo 10, what are the results we can get? Anyone? No? Any number modulo 10, what are the possible results? So results are from 0 to 9 and no other results are possible. So that's because, like, if we divide anything by 10, we can get the remaining part can only be 0. That means that division is fully done. Then 1, 2, 3, 4, 5, 6, 7, 9, and that's it. It cannot be 10. Otherwise, it means that we can actually divide by number. So so this is the key advantage. Key advantage that the modulo returns limited result of the operation, and this is really important when we actually need to have it. For example, when and here I can give you one example I had, and my colleague has had. It is so what was the task? The task was maybe I will not give you the full context now, but the actual task was that we have the IDs. Yeah, the IDs, the numbers, or simply the text, we can not transfer, but translate into the numbers. And then, so we had the list of the IDs. Yeah, so like let's say thousands of IDs we had. Like actually, we had tens of thousands or hundreds of thousands. I don't remember. And the thing is that we had to create the hash function which groups all these hundreds, thousands of IDs. Yeah, so we in hundred groups. So we have 100 groups, 100 slots, and we had to spread these IDs randomly. Maybe not randomly, but using the hash function. So it means that practically they should randomly go into one or another group. But so since we have the hash function, so it means that if we have a hash function, it's not really randomly, because this is the function, because all the functions can only get one result. One result. This is basically the definition of the function. Function cannot have multiple results. Yeah, so like if you have the function f, like any function, and you provide one fixed parameter, then you can only get one result. You cannot have, let's say, so this time I had function f, then I put the value 3, and this time now I get 5, and then later on I can get 7, for example. No, if you have the function and you pass one exact parameter, you should get only one result from this function. This is basically simply the definition of the function. Okay. And this is how it goes, and that's why we can say it's randomly if we define hash function which groups the elements into the groups. But yeah, practically, in fact, this is still the function. And then basically what we had to do, first of all, we had some requirements that the spread should be it should be random, but it should be equal. So it means that, like, if we have hundreds of the elements, it means that we should have pretty much the same amount of the elements to be placed into each of these 100 groups. Yeah, and that's why we implemented this function, this hash function. And so we basically use some random mathematical operations like multiplications, divisions, square roots or something similar, and at the end, every time after each operation, at the end we used modulo, just simply to place to get one of these 100 groups. Yeah, so basically to be able to write some kind of function to place to get let's say maybe the group or something similar, 1 out of 100, then at the end we need to use modulo 100, and then we get one of these 100 groups result. Yeah? So modulo is mostly used to get the result, which is limited in some kind of range from 0 to basically the modulo -1. Yeah. So this is the point for modulos, and I would say this is quite practical usage, because the result cannot be out of range. Yeah. So this is what we have about modules. So is it more clear?
Yeah, I guess. So basically it's not dividing anything, right?
It's dividing, and then we get the remaining part of the division. So we divide x by 2, and then we get the remaining part. So what is what? So when we divide something, we get the result. So let's say if we divide 10 by 3, so we have 3 at the result, and we have 1 as the remaining value. Yeah,
but in this case, for example, list add is 12, so we are dividing 12 with 2. Right?
we divide 12 by 2, and so then
it's 0, right?
Yeah, the remaining part is 0.
Okay.
And if we divide, and if we divide, let's say 7 by 2, then the result is 3, and we have 1 as the remaining part there.
Yeah, I get it now. Yeah, thank you.
So, but I mean, in practically modules they can be used to, as I just said, to split into groups, for example, and then to basically have the situation when you have the limited result range for the result. Okay. So, okay, and maybe one more. Yeah, okay. See, I almost I think it's good. So I can push this and open it. So yeah, okay, let's wait. So it's basically change the number is wall. Yeah, in this case, division is wall. Yeah, division is wall, and if it's wall, then it's 0, and if it's not wall, then it's 1. Yeah, so basically that would be the same if we say 1, because like if we divide by 0, then on the remaining part we can only get 2 results, 0 or 1. And also division by 2 is also frequently used for the binary operations. Like let's say that you have 2 binary numbers or something like this. So it means that binary means only 1 or 0. You have something like this. Then you do some operations with them. So, and to basically not go out of the range, I guess if we multiply 2, then this would be like we have, let's say, I guess 1 plus 1 modulo 2, that would be 2 modulo 2. This is 0, then 0 would be 0, 1 plus 0 would be 1 divided by 2, the remaining part is 1. So modulo 2 is also frequently used when if you work with the binary numbers. There may be such cases. Usually it's so if you work with the binary numbers, it's usually, I guess from my experience, when you do some cryptography tasks or also some hashing, it can be so usually binaries are used for cryptography. But and there then also needs to use the module 2. So if you work with binaries. But again, this is maybe more special case. But maybe in future you work with some cryptography. Then you need to use binary operations, and also then modules can be used as well there. Yeah. So. Yeah, but this is about module. Our initial topic was about the lambda expressions. Are they clear for you? And so we apply the function for inside. Yeah, actually, simply it means that we pass the function inside function and get some results. Okay, so hope it's pretty much clear. And so one more thing we can do before the break is I want to also show such approach of lazy object initialization. So this is also when we can use lambda expression. And basically lazy object initialization means that the object is initialized only when value property is accessed first time. So if an object means that its creation is deferred until its first use, so basically until we use it the first time, it won't be initialized. So yeah, let's try and see how does it work. So again, here we have orders. Two. One moment. Okay. Okay. So let's try something like this. Maybe better example. Okay, so here's the full example. Customer, and maybe let's check this one. So I will paste this class here and let's do it inside our main static void. Oh no, hold on, that was different. Sorry, I copy pasted the wrong one. My fault, sorry. Copy paste customer class. It should be better now. Yeah, okay, sorry, I also need to then okay, I also need to define orders type. Okay, so I guess the orders was not defined. Order type was not defined in the presentation. Okay. So moment. Yeah, okay, so it was not defined here. Maybe instead of orders, maybe let's use so I'm surprised why I don't have orders. Okay, maybe let's try to use the arrays maybe instead. So let's try this one, and I'll use the array instead of orders. So yeah, we have this lazy, and instead of orders, I will maybe use the array. So let's say that would be integer. Now maybe let's use the array instead, just to make it more interesting. So that is lazy. Okay, and then instead of okay, I already defined it. Yeah, so in this case it will define but not initialize, and let's see what will happen here. So not new orders but new string, and then I paste grammar here. So you see that we have the lambda expression here. So we have the lambda expression here, and yeah. So let's check, and maybe as an option, what will I do? So we have orders. But yeah, we have value, and then let's try to assign the element there. Yeah, by the way, this is also, I guess this is also indexer, if I'm not mistaken. So, and let's then maybe check how it looks in debugger. In debugger, so I will use the breakpoint here, and I will run the program now. Where's debugger? I can't run. Okay, it's a bit called green. Where's debugger? I can't run. Okay, maybe I can. Okay. because usually it works from right click. But okay, then we can use debug start debugging, and yeah, let's run the program and see how basically our object looks like. So, okay, this can be run, yeah, and then we are here. So let's move to the next line. Step over, and let's see how our elements look now. Yeah, okay, so the element is now initialized, and it can be used for amendments. Sorry. What have I missed here? Yes, now I have the valid property, and okay, then it was accessed. Yeah, I was a little bit surprised that when I pointed out, so I mean it. So here we did not access value, right? Yeah. But yeah, what I'm confused about is when I go to debugger. We're not interested in this part. And when we are here, okay, so here I initialize the object, I go to this one, and here I have not accessed the value. Okay, so I guess it's then maybe it accessed it from the breakpoint. Yeah, so if I point here, you see that I have the array here, so it's already created. So maybe let's then check it differently. So there is maybe let's write in console, and from the orders, you see that here is the getter, which checks if value is created. So let's check it before and let's check it after. We have different results here. So let's run. Let's see what we have. Yeah, okay, so now everything's fine. And that was just because that was, we tried to access it from debugger, and maybe from debugger that looks different. Yeah, so you see that before I access the element, before I access the array for the first time, and then the value is not created, so it's false. And after I access it for the first time, the value is created. Yeah, so you see that basically what happens, we don't just simply create the array when we don't need it. Yeah. So some cases we maybe have the situation when actually, for example here you initialize the object, but let's say you don't use it. Maybe there are some exceptions handling or some branching which does not allow us to, maybe does not allow, but it will simply not trigger the usage of this particular element, this particular object. Yeah, that's why we can use lazy instead, and this will then prevent creating the object which we don't use. So when it's maybe needed, in cases when you really worry about memory usage and also the usage of the objects, so especially when we talk about some maybe heavy objects, or for example, this may be some kind of web programming when we work with some multiple web forms or windows or something similar, views, then in such cases this may be important. For example, there may be some kind of so for example here, when we open Visual Studio, so what we see that these all are dropped. These all solutions are dropped. So we call them, I guess it's correct if we call them lazy. So it means that they are loaded lazy. So I mean this view is loaded lazy. So it means that I need to they will not be shown until I press this button. Okay. So I guess this is correct, and we call them lazy, because usually I sometimes work with such cases. Because in this case we call them lazy. It means that they are not loaded until we do some kind of initial action. So the same as here, the object is not created until I access it for the first time. Okay. So something similar. And so here I can then use on expression. Then it's actually what happens here. It passes the function, which then to be used when we access value for the first time. Okay. Do you have any questions?
Yeah, hello. I have a question, very simple, regarding lambda operator. What looks like, how would you how to ask this question? How would you translate it in the words? Is it something like follow or something?
So so here it simply means please. So previously we did some kind of functions. So right here by passing the parameters. But in some cases we may not need to pass the parameters to the function, right? So we just simply want to call the function. So this is what happens here. I don't pass any parameters, or for example, I can pass parameter, like that would be, I guess if I'm not mistaken, so let's say I have size, and then I think I can pass the size from here. So I don't need it actually. I don't need it. Because I can simply, if I want to use size, I can then provide it here. So since it's available from here, then I can provide it here, so it's not maybe really needed. But basically this means that when we go inside this constructor, then there are basically no attributes to be passed to the methods. So all the attributes, basically there are no attributes what we need to pass there. So this means you simply please basically it also means pass the function to this, and basically this is the function that needs to be passed there. A moment. So there was this input parameter, which simply means there are no input parameters. We simply then pass them to the statement, and so basically pass nothing to the statement, and we simply use the statement. So basically, in easy words, that would be that we pass the function, which will, so the function this method call new string, which then to be executed at value equals 0. I guess the first element will be would be elements. Then I think we can also let's try maybe this way if I'm not mistaken. No, I guess I can't. Maybe at this point I can't do it. But so basically this means that this would be the statement which this is the statement which will be executed when we access the value. I mean, we access our string array for the first time. So then it means that please execute this particular statement when we access this particular object for the first time. So this is what will be here. accessed, and then this particular function then to be triggered. Okay. So is it more clear now? And then
yes, thank you.
And this simply means pass no parameters. Okay, so are there any more questions about this? Okay, then I guess we can make a 10 minutes break. Yes, we can reach you at 7:47. Right. Okay, so it's 10 minutes break now. Okay, so there's some crazy stuff happening at work. Everything crashed, nothing works, basically, as it usually happens. Okay, so let's continue, I think. So, again, same question, do you have any questions about these found expressions? So yeah, maybe let's have a quick look in this example. So here, instead of initializing the so instead of initializing the array, it basically goes statements, and in fact, I guess we can then do multiple statements there. But I guess in this case there is no real reason, I think. So we can return and yeah, so we can then put it this way, or then let's say right here. Yeah, maybe let's say size. Maybe size. Yeah. So we can in fact write multiple operations. In this case, I don't really see if in this case I don't really see if we can maybe pass some arguments there. Yeah, I think at this point I'm not really sure if we can do it. But the fact is that we can also apply multiple statements here, multiple operations if we want. Maybe not in this case, it doesn't really make sense, but in other cases this may actually be possible, yeah. Okay, so in this particular case, there's the getter, so it returns. Well, so the approach is the same. So then there's lazy initialization for low overheat scenarios. So in the scenarios where you have to lazy initialize a large number of objects, so then you might decide that dropping each object in lazy requires too much memory or too much computing resources. So like in this case, in this case we have this ensure initialize, so I can check if the corresponding object is initialized, and so then I can check this. So yeah, this is about on the expressions. I guess we'll not have more topics about them. So do you have any questions about the expressions? Okay, then one more thing from this presentation. I will not go deep here, but I will talk about some small points. Yeah, first of all, delegate. Remember from yesterday, delegate means that we simply define a shortcut for corresponding function. Okay, so using delegate that is possible to do. So this was from yesterday. But yeah, so just in general, let's go back to the concepts of object-oriented programming. Remember that we first work with the references. So these are the addresses which points to the memory. Yeah, and then they basically describe the object. Yeah, so they store the position of the object in the memory, and this is how. So these are the values stored under the reference variables, under the objects. So yeah, this is the key point, and basically what happens when the object is created, then the reference is created. But so there is the lifetime of the object, yeah, some reference objects. So some objects might contain unmanaged resources. And in such case, yeah, so we have garbage collection, automatic garbage collection in C#. In C++, the garbage usually must be destroyed manually, yeah, but in C# that's not. And but in some cases, the garbage collector we cannot predict how it works. So in such cases, we may, not we, but yeah, usually we or some kind of libraries need to implement disposable interface, which has the method dispose, which then disposes the, yeah, it explicitly releases all the resources in conjunction with the garbage collector, and then basically makes the object disposable. So such classes, such objects, they implement a disposable interface, and then they have a dispose function under them. So we'll maybe not use this approach in our course much, but I'm not really sure if you use it on practice, but so you can see the pattern of using it. What I want to mention when this pattern is used, it is mostly needed for it was not mentioned here, but usually it is needed for some input streams, or I guess also for the connection with the database. It is used, if I'm not mistaken, if you use SQL. So it yeah, usually it's for input output, if I'm not mistaken. Moment, let me quickly check. I guess I had yes, I had a note about it. So that's all input output. So when you need to close the input stream and output stream. What else? Yeah, it was about maybe some regular expressions, I guess. That was also used, but I mean these are mostly the special cases, and maybe you don't need to implement them manually. So for example, when we close the input streams or something similar, then we used so some cleanup or some shutdown. This is used, but I guess these are mostly special type of object, special type of process, so we will not go deep with them right now. Okay, so I guess then, for charge sets have some kind of input output, then this may be needed. Yeah, also for some kind of web forms, Windows, like when the Windows is closed, then such disposable functions may be needed, but usually not with the simple objects we use. Okay, so I guess that would be it for this presentation, and we can move on to the next one. And next one will be, I'd say, maybe more practical. It is it is about core utilities. Let's start this presentation about core utilities. So basically, remember that in programming, it usually, like if you use some, let's say some simple, you want to do some simple, or maybe not so really simple, but pretty much popular operation, then it usually means that someone else created the code before you. So usually we as programmers, we do not invent our own codes, so we don't implement our own algorithms for maybe some kind of basic mathematical operations like sorting, something similar. Usually there are the libraries, there are the utility classes which do it. Yeah, so our task is to be able to find them and to be able to use them. And so these are the key points, and for such purposes, let's take a look on some core utilities we may use in C# and also in .NET in general. Let's take a look. So first of all, we use system namespace. So this is, say, must-have class. So let's say, not class but namespace. Yeah, and let's see what are the classes we have here. So we have lots of classes here, lots of classes, lots of functions. We can use lots of sub namespaces, collections, configuration, console, lots of different things here. So this is the system must have. It contains all the fundamental base classes that define commonly used value and reference data types. Yeah, so like integers, string types, and all these types we normally use, they are all defined under the system namespace. So events and event handlers, interfaces, attributes, exception classes, these all are defined under system namespace. And then processing exceptions. It contains the classes that provide servers supporting data type operations, method parameter manipulations, math operations, remote and local program application, application environment management, supervision, managed applications. So basically, we must have thing. And what else? Since you see that all the application we create, it has some related dependencies, some related files. So this here we don't have. Yeah, because here we don't have them. But under the project we do have them. So for example, maybe let's let me open this project and see how it looks inside the folder. So here. So yeah, we see we have some configuration files here. So this here, okay, let's open it in Notepad. Yeah, so see that we have some configuration like the target framework, output type executable. Okay, so yeah, we have these setups, and let's say that we want to access some setups there. So let's then go to system. We can go to configuration namespace and see. Yeah, we have some assemblies. Yeah, so those are the classes that allow us to programmatically access .NET Framework configuration, some settings, and handle errors which are stored in the configuration files. So, I guess that was not. I have only assemblies here. That was a little bit strange. Yeah, okay, I have configuration. Yeah, some settings base. I don't have it here. That was a little bit strange. Well, I have only assemblies here. Okay, so I guess there should not be difference if I find here. Okay, maybe let's move this at this point. I'm not sure. Okay. This was strange, but okay, maybe that's not so important now. This, okay, maybe this is more relevant for other project types, not console application, but it's still strange. It has only, should not have only one class. Okay, this is really. Going back and check it later. Why it does not show us this particular class. But yeah, so the key point here is that using the configuration namespace we can access some application settings. So like we can define some generic values, and usually for the applications we have some kind of like not only .NET but in general we have some kind of configuration files which store the base information about the application. In some cases it can also be some username, maybe not some usernames, but maybe one special username. For example, if the application is connected with the email box, email framework, then we can also provide some kind of username settings. Like for example, I recently worked with the application which is connected to my Google account, Gmail account, and then inside the configuration file I had to store the username, basically my credentials in Google account. Yes, so such parameters may then be defined in the configuration file, and they can be read inside the code. Maybe I guess that's because of the type of application. I can maybe check it later, but yeah, this can be accessed there. So yeah, so this is how these classes look like. Then we have yeah, so some globalization related classes. So let's say go to system, go to globalization. Okay, it's better now. So yeah, for example, usually yeah, so what is the point here? Usually when we work with also what I currently do, we work with the system which basically is applied to worldwide customers. So it means that we can have the users in different places in the world. So there may be the users in Japan, in China, in USA, Great Britain, Africa maybe as well, and other places in the world. And maybe so just some notes from my experience. What are the key differences in between the countries from the programming perspective? So first one is what I noticed is the date format. Yeah, so for example, I work with the project in Sweden, and they use not date format as we usually use, like it's day, month, and year. So in Sweden they use, I guess that may be differently, but usually, at least from my experience, is year, month, and then the date. Yeah, so sometimes some people use also year, day, and day the month, then the month. So there can be some crazy date formats. So yeah, that's why. And the thing is that like usually the program is created for multiple cases. So the program needs to understand all this data and convert it properly. So that's why we may need to have such tools. Also, yeah, so in Sweden they like to use the week numeration, like the first week of the year, then the seventh or 70th, no, it won't be, the 13th week of the year, and so on. So they like enumerate the weeks of the year. Yeah, so it can also possible, and actually then maybe to convert the date into to find the week of the year, then such some classes, maybe special methods classes may be needed. So yeah, first is about the date format, because it is really different, and maybe not only across the countries but also across different systems. Usually it's may trigger some issues. Yeah, so first about the date, then about the time zone. So time zone is also it may be important, especially if again we have the application which works worldwide. So it means that in different countries the time zone is different. So such conversions may be needed, and so yeah, this may also be a little bit complicated, but usually it means that we need to use some kind of special tools which can do this. About the time zone, also important thing is the daylight saving time. So some conversions may be also needed there. So because again not all the countries use daylight saving time, so it means that we simply turn the clock for 1 hour forward or 1 hour back. So we switch the clocks. Not all the countries do it, so this can also be a part of globalization checks. So then, as another example, this would be what we have is what kind of issues we may have when we work with the global applications are the characters. So different countries, different languages use different characters. So that's why we may need to have some conversions, like I currently work with them, Chinese and Korean customers, and so then there are some multiple conversions in the systems needed to convert from to Chinese or Korean characters. So Hani and Hangul, they are called. So such conversions are needed. Then also we need to use some special information, special utilities. This is interesting. No, this is for culture information. What is this? Provides information about specific culture called local. What is this? This looks interesting, isn't it? Okay, this is the class. Okay, there is the method get culture info. What is this? I never noticed this before. Let's check. Where is this? I said this before. Yeah, so even such information, agriculture information. System level, okay. Retrieve the cached return instance of a culture by using transfer return culture info object. Okay. So, and where is the issue now? Okay, culture. I need for the integer. So let's say the culture will be O. Not sure what O will be, but let's see. Yeah, so it's just for fun, but yeah, so even the information about the culture can be returned by the utility classes. So let's see. I never seen this before, but about the culture, what can be returned? But let's see. What does it look like? Okay, 1 moment. Okay, the parameter is not correct. Let's maybe provide another parameter. Okay, it has 3 overloads. Let's have a look what does it expect. Yeah, actually, but always it is. Yeah, you can. By the way, if you want, you can also navigate to each method and see basically maybe some description. So we can also debug if you want. Yes, then have a look through. Wait 1 moment. Yeah, culture info. I guess everyone is searching for it. This looks interesting. Let's have a look at it. Okay, so we have culture info class. Maybe let's have some examples. Okay, so here we have Spanish culture. Okay, let's then check this one. Go back. Let's repeat. Same approach. Yeah, okay. Let's try. Okay, just simply says. Okay, maybe I can check it later. But yeah, so that is just for your information, and we can have such, I would say, maybe a little bit crazy methods from the utility class, and sometimes they are really important. Again, for example, to find out what time zone each country use, what calendar the corresponding country uses, and so on and so on. So there are lots of things you can check under the utilities, like Japanese calendar, Korean calendar, maybe some other types of some other calendars. Yes, so lots of different things you can check, because currently the world is really globalized, and then lots of different things need to be taken note, and then we need to be able to find out some more information about such things, yeah, like daylight time. Yeah, so it searches for the period daylight saving time. Calendar represents time in division, like weeks, months, and years. Yeah. So okay, then it's about some called culture sensitive string comparisons. Okay, yeah, that is, yeah, that's mostly about it. So like yeah, some like special properties. Yeah. Okay, so region info, information about the country, number formats, and some similar things. But yeah, so this is this was about the globalization, and I would say one of the most important system classes is string. String, we already use string a lot. We already know what is it, what is it, what does it have. So we all know what are the parameters stored under string, like the length. So then basically the string itself is, we know that it is the array of characters, read-only characters. We cannot change the array. And we also have some, remember that the string is not a value type, it is a reference type, because it's stored as object, as array. So this is the object. So this is the reference reference variable. Yeah, so it's not like integers or numbers or characters or something similar. It is specifically the reference object. And we all know that strings have the methods, like we can compare two strings, compare two. We can check if two strings are the same using equals, check what is the first, the last character of the string. Then we can check some kind of elements of the character or of the string, and so on. It's also lots of different methods we can call from the string objects. And so basically how the string class is implemented. Oh no, it's like, yeah, we can create a custom string, but so we can do lots of things there. And basically what is interesting is that all the object, but inside the object class, so it means that all the reference variables, all the reference values, they have the representation in form of string, because all the classes have two string methods. So it simply means that we represent the object as string. So by default it is just the value of the reference, the value of the pointer to the memory. But if we override it, it usually means that we write the method which represents then the object as the string as we want. So we can write any logic there, and then return any string, any representation of the current object. But so for the strings in general, we can do some different things, like we can do the concatenation. And by the way, this is not this is not preferable approach. Yeah, so for concatenation, oh no, sorry, this is fine. Okay, it's not done. Well, okay, so it's fine. But if we do it in loop, please do not use strings. Yeah, so remember when so this is important, so maybe I will also explain about this. Remember we used string builder, so that was from the text class. Okay, so this is sorry, namespace. Remember we use string builder. So we use string. Let's say that we have a situation when we need to build a string, which means that we have like an unknown number of concatenations. Like let's say we have the loop where we need to concatenate the like multiple strings. So what we do then, we don't yeah, of course if you want, you can like you can use simple concatenation of the strings like here, like it is here, but we normally do not do it. We don't concatenate strings and loops because remember that every time you create new array, new object, okay, then this takes lots of, not lots of, but this is not really efficient. It's not very efficient to create and copy the arrays every time, and then for such purpose we better use string builder. String builder, it is more efficient way how we can, yeah, usually is how we can construct the strings, how we can concatenate strings, and it is significant when we work with the loops, for example. Yeah. So for the loops, string builder is definitely better than the simple concatenation of the strings. Yeah, so it is important. So basically, yeah, for the strings, as you know, we can call some methods like check the index of the corresponding when the corresponding substring or the element starts at. We can get the substring, yeah, by providing the starting position and the ending position of the substring, yeah, so where we start and where we end. Yeah, and then we get the substring from there. So, yeah. So what else we can do? Yeah, all the objects have the method toString. So it means that they will return the string, yeah, which represents the corresponding objects. Remember, that's why we usually override this method. Yeah, we override toString methods to write the representation, string text representation of our object in the way that we want to show it, maybe on screen or pass it somewhere else. Yeah, it depends. Okay. Oh yeah, by the way, a culture info, we, for example, can use the transforming of the strings. So, for example, like if we have that small value, then it shows, yeah, so then it shows the cost, and yeah, so then we can use culture info of United States. Then the cost value will be shown with the dollars and the separators will be used. Yeah, for example, yeah, also the thing I recently had on my work is that, yeah, that's why globalization may be important, is about the way how the currencies are displayed. Why it is important? For example, the countries like Korea and Taiwan, they have their own local currencies, and for example, Korea has they have wons, Korean wons, and for them they have like the exchange rate is, let's say, quite large. So if I'm not mistaken, so about $100 is about 80,000 wons, if I'm not mistaken. So a moment, let me check to. No, okay, it's a little bit more. So yeah, $100 is 190,000 Korean wons. And what the thing is? The thing is that, let's say that you have some kind of items displayed in the application, and so let's say that you have the item which costs maybe some thousands dollars. Yeah. So then, of course, in bonds that would be much larger number. And then the thing is how you want this number to be displayed. Because, for example, for Americans, they have such format, such display, it's fine for them. But for Koreans, like, they have their wons, they have their currency, and then let's say they may have lots of zeros or lots of characters. Then, of course, like if you have such number, I cannot edit here, but like, let's say, imagine you have the number was 1,000, let's say maybe 10 or maybe more characters, then of course it may be hard to read it. It may be not how the users normally read it. That's why we need to use globalization to find out how it looks like. So for example, maybe let's copy paste and check how this will look for Korea. So you see how it looks for United States, but let's say we want to check Korean bonds. And I guess, yeah, they don't use decimals. So let's say that looks something like this. Let's run, and that can be correct. Not dollar, but KR. Guess this will not trigger the issue, the exception. Oh no, it's just simply trigger nothing. Let's go back to this one, and let's change to Korea here. Oh yeah, so you see how it is displayed. Basically, since we have, I'm not sure why we have a question mark here. Okay, the currency is not clear. Let's try it, and here we are, but the language, Korean language, is KO, usually, normally, if I'm not mistaken. So let's check once again. Let's try again. Okay, for some reason it's now shown at the end, but you see that it is different from what the Americans use. Yeah, so they use the spaces, for example, or other countries may prefer some different options. So that's why it's also really important, especially also for the currencies, to check what's the formats that each country uses. And sometimes you may have one application, you may have one price, but then the customers from other countries see it differently, based on their globalization settings. So this will be quite important too. Yeah, also for the date format, like, so let's also take a look on this. So for example, yeah, let's check how this would look for, yeah, for French, we're using as date, month and year. Yeah, so let's check how this would look for the United States. United States, I guess then there should be year, month, and day. Yeah, so see. Oh. Minus. Oh no, yeah. Then it's month, day, and then the year. Okay, so crazy formats. Let's check what is for Sweden, for example. Oh no, how was the Sweden file? Let's check how was the Sweden file. Sweden, what was the ISO of Sweden? So. Swedish, that's ISO, currency. Okay, it's SE. Okay, so it is SE. Let's check this. That should be this way. Yeah, so in Sweden, you see that they use year, month, and date, and also it's important what is the separator they use. Okay, so different countries use it differently, so please remember this when you work on different projects for different countries, since this may be really important. Okay. So, yeah, also for currencies, so when parsing number, so let's say that the string is provided, then maybe the number needs to be parsed. Yeah, for example, if there is the number with the currency passed, then let's say we want to get just a simple number without any currency or something like that, right? Then we also can use try parse. Then we can also apply some currency settings, yeah, like the culture setting, and then get the result. Yeah. So also an important thing. Do you have any questions about globalization class? Or maybe any question about when we need to use it in practice? So then I hope it's clear. Okay, then the next one is the text. Namespace. And as I just said, remember that we used string builder for here. But so it also has some other features, like it represents encodings. So sometimes there may be the need to encode or decode the text, the string. So usually it's maybe because of the character formats, or the character set. We use usually we use UTF-8, but there may be some other character sets. So it's then really important to sometimes to encode the text into one format from another format, and that for such purposes we can use the encoders, decoders to translate these strings. So, and string builder, so it's separate, but it's also very important. It helps us to construct the string. It creates the instances of the string, but yeah, it's effective when you have lots of different operations on the string, like you change the string frequently, and then usually if you do it in loop, again as I said, then please use string builder. Okay. So yeah, this is how it normally works. Like if you want to append some new elements, not elements, but some, like if you want to concatenate the strings, then you can call the method append. So first we construct the builder, string builder. We can provide the initial value there, and after that we can append. It means I concatenate a new string there. Then you can insert at some kind of position, special position provided. It's also possible you can remove, replace, and so on. So in this case, it is really effective when we change the string. Because it works in a more effective way compared to if we just simply concatenate and create each concatenate or change the string every time. Because remember, strings are not mutable; they cannot be changed. If you make adjustment in string, you actually create new objects. So that it creates new array. It copies all the elements from the previous array, so it's time consuming and also memory consuming. So it's not really effective. And instead, please use string builder. If you want to do the manipulations on string. So do you have the questions about string builder? So remember, every time you want to, let's say, construct the string inside the loop or do something similar, if you have some like a few operations on string, then that may be fine. Then you don't use string builder. But if you do these operations, let's say again in loop, then please use string builder. Okay. Do you have any questions then about the text class or text namespace? Okay. Then if not, we also already used system math namespace. So this is the namespace which stores the main classes, the main basically, I guess that's, sorry, system math, I guess that's the class, that's not namespace. Let's double check. System, so this is the class. By the way, how you can search for the elements, you can use control space, and then here you can filter out if you want to show the namespaces stored under system. You can select namespaces. If you want, you can select classes, so you search only for classes, and they are displayed this way, so you can distinguish them. Then you can search for the structures, and then for the interfaces, for the nums, and for the delegates and the functions. So you can filter out what you want to search for, and filter nothing, then it will search everything. Okay? Just for information, you can do it. And system math, this is the class which provides us the key operations we can do, key mathematical operations we can do. So like some functions like rounding, find sine, find square root, so what else? can get, you can check some numbers like p number or e constants. Check some constants. You can do it in math class. So basically all the mathematical operations you can take from math class in case it is needed. Okay, so do you have any questions about system namespace? So some old basic system operations, they all are defined under system, or the classes, they are all defined under system namespace. So, okay, then if there are no questions, then I have a question to you. How is your activity 4 and activity 5 tasks? How are they going for you? How are you progressing on them? So, are you progressing?
I started the 4th activity, almost finished, so the 5th is still is necessary to finish. So there's some little thing that's not working still, but little to work.
Yeah, that's good. Because maybe on Saturday then I want to go through, so we can go through together and discuss maybe some things. That's why. That's
tomorrow,
why.
So
that's why I'm asking. And, that's fine. And
tomorrow evening is time to finish.
No, so I want to maybe. So currently, guess we can maybe finish with the presentation now, and I can give you the time to progress on your activity 4 and 5, and maybe in case you have any questions, you can ask me. I'll be here. Okay.
Yes, it will be fine.
Meanwhile, I will then push the code to GitHub. So let me then do it. Code. Git commit. Remember. Push the code. Okay, so maybe let me take 5 minutes break now. So then I will be back in 5 minutes. Okay. So meanwhile, then you can go to school. And not finished activities 4 and 5, then you can continue. You can continue on them. Then I'll be back in 5 minutes. Okay. Sorry, Elena, I have not noticed your question. Okay, maybe I would then go back then to your question in 5 minutes. Okay. Sorry, I haven't noticed this. Okay, so I will answer to your question in 5 minutes when I'll be back. Check. Okay. Okay, so, the question from Lena, can I explain activity 5? Okay, let's have a quick look on it. Just 2 moments. Oh no, two tasks. What? 3 hours. Then I think it's 285. So let me open it. Yeah. So here what we have. In this activity you are going to extend the existing player profile class to create the card player class under the namespace. Yeah. So basically for this you need to add both player profile class, previous one we had in the previous activity. That was here, right? Yeah. Let's check. I guess here we had it. Yeah, we had this player profile, so please use this player profile class. Yeah, and then add it to your current solution for activity 5. So this is the first thing. You need to take it and then place it to your current solution. Yeah. And you need to extend it. So it means that card player will be the subclass or of player profile class. Right? So you need to then extend it, like just simply you can work in the list when we put together. So I will Okay, we want first to open the solution for activity 4. No, sorry. I guess, okay, I need to create a new one. Sorry, yeah, let's create a new one. Okay, class library. Activity 5. Tasks. So yeah, let's create a new solution. Okay, so I delete this class. Then I add the player profile class. Oh, so one important question. Okay, so tomorrow colleague. Okay. Sorry, just noted one, because like actually currently there's a strange situation for my work, because like I work in the project where the base things happen in Asia, in Korea, and Taiwan, so it means that the key part happens during the morning time, so first half of the day. Then there are the developers who are from Switzerland and Morocco and Spain. So yeah, for those who are from Switzerland and from Morocco, they mostly work during the daytime. So as we usually do, sometimes it's until 7, and then there are Spanish developers who work usually at this time. Not sure why, but yeah. So for me, that's why it means that I have such a crazy spreads starting at 7 o'clock, and it's then finishing somewhere around this time. But yeah, so that's just a funny thing. So let me add the player profile. Okay. Player profile, and then I need to extend this player profile class. Here I can create an item. And this would be card player, right? Yeah. Card player. And then this will extend. So it says it should be under the namespace C# activity card game. Oh, so there we go. Instead I need to extend player profile. Yeah, I also need to change player profile. C# activity profile. So C# activity profile, and then I need to extend player profile. And yeah, so then I need to extend this class as needed. So then the interface called iCard is already provided. You will learn more about interfaces in the next activity. So for now, focus on the card player. Okay. So for the card player, let me check where's iCard player provided. Moment. Okay, sorry, I need to then take it from here. So I need to take it from here. It was not said that I need to add it, but I need to. Okay, so I need to then add it from here. Okay, so is that true? Activities, code files. So yeah, so you see I have iCard interface here, and I can add it to the solution. Let's add it. And so this is for the card. Yeah, so we need to add it here, but at this point, yeah, so it's provided, I don't touch it for now. So then the card player class has similar characteristics in here as the basic player profile class, okay, but with existing difference. It is specifically designed to have a hand of card, object, and behavior specific to manipulating that hand. Yeah, so it means that since it is the player, it's a card player. It means that it should have the cards in hand. Yeah, so then you need to find a way how you store the cards. So it can be usually it can be the array, it can be the list. Yeah, so you can use the collection here. Yeah, so you need to think about, maybe you can use array if you want it here, and then store the cards, the card objects for this particular player. So this is the second step. You need to design and implement this particular point where you need to add the parameter where the objects to be, these cards to be stored. Yeah. So this is done. Let's say this will be done. Then we need to create card player. Okay, it's we already done it before. Okay, it's subclass. This automatically grants it access to. Okay.
Yes, I can.
Sorry. So what was the question of? So is the here. Okay, looks like some connection issues. There's something similar. Can you still hear me? That's right here. Can you hear me?
Yes, we can.
Okay, and so what was the question from someone of you? Okay, good. But what was the question? Because someone of you asked the question. So that's okay. Then just in case you have them, please re-ask. So yeah, then what happens then? Basically I already done the first step, and then create a class simple card. Okay, that will be the next one, and inherit it from iCard interface. Okay, I guess then you can do it. So I cannot just I will not just simply repeat the steps that you should do. So then we create separate class and inherit from. So you extend, basically implement iCard interface. So you create another class. Then you will be required to add the objects of simple card, the class card player. Be developed in step 5 below. So that will be the next step. Then you need to implement the following behaviors for the simple card class. And inside simple card class, you should have card attributes. So that would be the attribute, with getter and setter, and this should hold the attribute of the card. So integer attribute for testing, we can assign number like 1, 2, and so on. And the next one would be the method which comes from the interface, get card attribute. So this is the interface we have, get card attribute. So it means that we need to implement it under the simple card class. So when you create simple card class, okay, I guess we can do it now. Why not? But yeah, this is what I would ask you to do. So simple card. Let's say I use the same namespace, and then this should implement that part. And so you see that it requires us to implement get card attribute. So this is what you should do, and it simply returns the card attribute concatenate with a string. What's the question is what will be the string? No, actually, I guess it's formulated a little bit crazy, I would say. I guess that was a little bit crazy, but simply need to return card attribute and concatenate with the strings. That's just the way how we can convert integer to string, but better than convert this integer to string. Then it will be up to you to determine how to implement the hand of cards. So this is what I said. You need to find a way how you can store the cards under the card player class. So it means basically you need to find a way how you store the cards for card player. So it can be the array, it can be any collection you want, you can implement. So this is up to you to decide. You add this attribute to card player class, and then this attribute should store the cards for the player. Okay. So it will be up to you to determine. We need some kind of data structure. This is what I just said. It can be the array collection, or you can create your own. You can create your own way of storage. As we've seen in the previous course, we can implement some kind of linked list or something similar. So if you want, you can also implement something like this. This is up to you, and the only restriction is that the implementation must be indexed. That is, the first card added is 0 and the next one is 1. So that would be the option. And so you can, in the hand you can use an instance of for example, you can use array store as an option. That can also be the variant for you. So, and then you add the check class, the test, which you can then use in the unit test. And so then you can check what are the behaviors. So first of all, you need to implement the constructor. So this should create a player with the specified name, gender, date of birth, and the maximum number of cards. So this is what you need to then implement. Next one is add card. So you can add card to the hand of the player. So this will comes from one. So it means that this method is called, card is passed, and then the card is then put to the collection when you store, the data where you store the cards for the player. Remove card. So the option will be to remove the card, check if it's full. So you can then check if the hand is full. So you can check if the hand is full, like the player cannot take more cards. So that will be the option as well. Then get card, to retrieve the corresponding card, find number of cards in hand, and check the maximal size, what can be possible to hold in hand. So in theory, like if you play simple cards, simple card game, then you cannot have more than 36 or 52, depends how many cards you use. So I guess that would be the maximal size you can hold in hand. And so then once you complete, then I guess in form you need to then just simply submit. It's push it to your remote repository, then we can check it and so on. Do you have any questions about it? So is it more clear now, or what exact maybe is there? So I guess maybe for this particular constructor is not clear, but remember that card player, it is the subclass of the player class, so it means that it should call the constructor of the superclass as well. So it means that we have the player, the player profile. See that it has string, gender, and birth date. So it means that when we call the constructor from the subclass of the